Hello students, welcome, and here we are again for the next session, and the topic is multiplication of matrices, and this is from the chapter matrix of class 12th. So basically if we talk about multiplication of matrices, there are two matrices given to us, A and B, and the resultant is a matrix C. So first thing is here that they are conformable for matrix multiplication, conformable. So what do we mean that the matrix A and B are conformable for matrix multiplication? It means that the number of column of the first matrix, that is A, is equal to number of row of the second matrix, which is B. So if A is a matrix M cross N and B is a matrix N cross P, then we can say they are conformable for matrix multiplication. Why? Because the number of column of the first matrix and number of the row of the second matrix are equal. Similarly, we can also have to understand here that it is not necessary that if we find out A into B, A multiplied with B or A pre-multiplied with B, then A is also post multiplied with B. It doesn't mean so. So even if A into B exists and there is C, which will be the resultant matrix, and what will be the order of the resultant matrix? That will be M cross P. That will be M cross P. And what are the values? We will discuss the values also. But first we have to understand here that if A and B exist, that is A multiplied with B exists, then it does not mean that BA exists necessarily. It may be possible that they does not exist. Why? Because it may be possible that A is a matrix which is 2 cross 3 and B is a matrix which is 3 cross 4. So what will happen? A cross B will be a C matrix, which will be, which order the matrix would be, students? It will be of 2 cross 4, and it is conformable here. Why it is conformable for multiplication? Because the number of columns and number of rows are same here. Now if we say that we want to find B into A, that is B is pre-multiplied to A. So B is 3 cross 4 and A is 2 cross 3. This cannot be multiplied like this in this order. So if we see that AB exists, it does not mean that BA also exists, but it may exist also. Like if we say that AB is 2 cross 3 into 3 cross 2, then the resulting matrix is 2 cross 2. And if we change the order here, so B is 3 cross 2 and A is 2 cross 3. So can we multiply here? Here it is conformable because it is 2 and it is 2. As it was here 3, it was 3. So the resulting matrix is a matrix which is D matrix and it is of 3 cross 3. So you have to understand that A multiplied with B does not mean B multiplied with A. So here we won't say multiplied, instead we will say pre-multiply or post-multiply. Like here A is pre-multiplied to B or B is post-multiplied to A. Here the multiplication is not possible in this order. When B is pre-multiplied to A, then the multiplication of the matrices in this order is not possible. Here A is pre-multiplied to B or B is post-multiplied to A. Here again B is pre-multiplied to A and A is post-multiplied to B. So if you observe here, in all these situations we have a clear concept here that A into B, A pre-multiplied with B or B pre-multiplied with A are two different things. They are not the same things. Now what are the values actually? So if we talk about the values, there is something like this, that A is having the element Aij and it is of the order M cross N. B is having Bij and it is of the order N cross P. Then C is the multiplication of A into B, which is having elements Cij, and the order will be M cross N. Now the question here is The order is of course this m cross n, and the n is common here. Now the question of course here is, what is Cij? So Cij basically is equal to multiplication of Aik into Bkj, where k is equal to 1 to n. Now how to understand this complex equation? It is not at all complex if you will try to understand. Let us take an example. I am taking an example. Suppose we want to find C12. Okay, that is, we want to find the element which is of the first row and second column. So first row and second column, this element we are talking about, C12, first row second column element. So what will be its value? Its value will be, if we see here, C I is 1, j is 2, k varies from 1 to n. So C1 1 and B1 2, right? Then C12 B22, then C13 B32, and it goes like this till we exhaust all the n. So this is the formula what it means, that is C12 is actually C11 B12 plus C12 B22 plus C13 B32 and C1n into Bn2. So what is happening over here, if you see it with the perspective of matrix, it is having element like this, A11, A12 and A1n, and then we have, this is A1n like this, and then we have A21, A22 until A2n, and then we have AM1, AM2 and AMN. So this is M cross N matrix. Now what is B matrix? B matrix I am writing it here. So B matrix is N cross P matrix. So B11, B12 and B1P and B21, B22, B2P and so on till Bn1, Bn2, Bnp. So we have these two matrices before us. Now when we multiply them like this, what is happening over here is that I am taking C12. So I am talking about this particular element, which is the first row second column element of the multiplied matrix. So what will be that? A C11. Actually I have done a mistake here. This is A here. This is not C. This is A. This is A. And this is A, because we are talking about the first matrix into second matrix. So these are the elements of the first matrix and next one is the element of the second matrix. So I just mistaken that as C, that is actually A. I hope you have got it. So this is not C, this is A. So if we talk about A11, B12, so A11 is multiplied with B12, right? Then A12 is multiplied with B22. So A12 is multiplied with B22. Can you see what is happening here? Now A13, this third element, is multiplied with B32 below this. So there is a row here which is the first row, this is the first row, and there is a column here which is the second column. So the first row of the first matrix and the second column of the second matrix are actually getting multiplied here. This is what is happening here. What is happening over here? That a single element of the multiplied matrix is actually multiplication of corresponding elements of the first row of the first matrix and the second column of the second matrix, and we are adding them up. So what is happening, that A11 is multiplying with B12, A12 is multiplying with B22, A13 is getting multiplied with B23 and B32, and similarly A1n is multiplied with Bn2. So this is a column and this is a row. That is why you have to understand that the number of column of the first matrix should be equal to number of row of the second matrix, because if it is does not like that, then this corresponding multiplication will be mismatched, because the elements here in this row is same as the elements here in this column. Why is it so? Because the number of column of this matrix is equal to number of row of this matrix. Then only we have the same pairs. If there are 5 in this row, then there are 5 in this column also. That is, n is same. So this is one element which we are getting. So if we now see an example here, so I am giving an example and we'll see the matrix multiplication. So what happens here is we have 2, minus 1, 3, 0, 1, 2. This is a matrix which is of 2 cross 3, and I am taking another matrix 3, 2, minus 1, 3, 2, 1, 0, 1, 7, like this. This is 3 cross 3. So if we take these two matrices, then what happens? Then when you multiply these two matrices, then the resulting matrix would be obtained. Like this is 3 and this is 3. So it is conformable for multiplication, right? And the resulting matrix will be of what order? So as you can see clearly that the resulting matrix is number of rows here and number of columns here. So 2 cross 3. Now if we want to write the answer, so we are talking about the first row, first column element. What is that? C11. So C11, what it means? Actually first row and first column. So I will take first row and I will take first column. So when you multiply 2 with 3, you will get 6, right? Then you will get minus 1 into minus 1, that will be plus 1. Then you will get 3 into 0, that will be 0. So this is how you will obtain it. Then you will come C12 here. C12 is first row and second column. So what is happening? 2 into 2, 4, and then minus 1 into 3, minus 3, and then 3 into 1, 3. So this is first row, second column. Now we talk about the first row, third column element. So first row the same, and this is the third column. So 2 into 2, that will be 4, and then minus 1 into 1, that will be minus 1, 3 into 7 is 21. So this is how we have written this first row. There are 3 elements there. Now second row we are talking about. So what will happen to the second row? Now C21, we are talking about first thing is C21. So second row and first column. So 0 into 3 will be 0, 1 into minus 1 will be minus 1, and 2 into 0 will be 0. Now we take second row and second column. So it would be 0 plus 3 plus 2. 0 plus 3 plus 2. Then we will take second row and third column. So it will be 0 plus 1 plus 14. So what we are getting finally, we have this thing which is 7, and here 4, and here 24, and here we have minus 1, here we have 5, and here we have 15. So this is 2 cross 3. So we get this matrix which is 2 cross 3 after multiplying these two matrices. Can we multiply this matrix pre-multiplied with this matrix? That is not possible, because here the number of columns are 3 and here the number of rows are 2, which are not equal. So we cannot multiply in the reverse order. So this is the matrix multiplication. In short, you can understand like this also, that we have a matrix which is having rows R1, R2, R3 like this, and there is a matrix which has columns C1, C2 like this. Suppose for our general understanding we can write it like this, and then we are multiplying them. So since the number of column of this and the number of row of this is same, okay, so what is happening over here, that we can say that row 1 is multiplied with column 1, first row is getting multiplied with the column 1. So the number of column is equal to the number of row, that is why it is getting paired up. Then R1 C2 is the next element. So this is not an element, this is a whole row, this is a whole column here. So it is just a denotion, R2 C1, R2 C2, and R3 C1, R3 C2. So this is how you will get the resulting matrix. So in this manner also you can remember row, it is actually a row to column multiplication. Matrix multiplication is a row to column multiplication. So you have to multiply rows with columns and you will get the elements of the resultant matrix. So this is how you have to understand this. So this formula, if you have seen here, this is initially complicated, but when you will come across this example and then now you will think about it, you will understand that any element Cij of the resultant matrix is actually Aik into Bkj from k is equal to 1 to L. So now there are some properties and something regarding multiplication of matrices. First thing, it is quite clear that matrix multiplication is not commutative. That is, if AB and BA both exist also, then also it is not necessarily that they are equal. Both matrices are equal. So A into B and B into A are not necessarily commutative. That is, even if they both exist, A into B also exist and B into A also exist, and even if they both exist and are of same order also, like if A is of 2 cross 2, B is also of 2 cross 2. So the resulting matrix will be of 2 cross 2, and B is here 2 cross 2, A is here 2 cross 2, then the resulting matrix D will be also 2 cross 2. So here the order is also same. In one example earlier, we saw that both the matrices were occurring, but the order was not same. Here the order is also same. Then also it is not sure that it is not necessary that C is equal to D. This is not necessary. It is not necessary that C is equal to D. So first thing, that it is not definite that A into B exists, that means B into A also exists. Even if though both exist, they may not have the same order. Even if both have the same order, they both may not be commutative. So these are some of the things which is layer by layer, it has to be clear. One more property is very important here, that if there is multiplication of A matrix with B matrix and we are getting a null matrix here. So does that mean that A or B, any one of them is null or both of them is null? Like in numbers, what happens that A number multiplied with B is equal to 0. So either A is 0 or B is equal to 0. This is what we know about numbers. But in matrices, the algebra of matrices, it is not necessary. That means A, B could be equal to null matrix even if A and B both are non-zero matrices. So even if both are non-zero matrices, then also their multiplication is a null matrix. Now if we see here, what happens that, let us take an example. A is a matrix 2 cross 2 like this. Let us take like this. B is a matrix like this. So I have taken a matrix, it is not null. This is also not null, this is not null. You already know what is a null matrix, where all the entries are 0. So here not all the entries are 0, here also not all the entries are 0. Now let us multiply them, A into B. So when we will multiply A into B, what will happen? A pre-multiplied with B. So first row with first column you will get 0. Then first row with second column you will get 0 again. Second row with first column you will get 0. Second row with second column you will get 0. So here you have to see that A into B is a null matrix, though none of them was a null matrix. So it may be possible that the product of two matrices is a null matrix even if both the matrices are not non-null matrices. Another thing is that, can we find out BA also? So of course we can find BA also. B pre-multiplied with A. So first row 0 1 with first column 0 0. So it would be 0. Then first row here and first column here. Sorry, first row here and second column here. So it will be, this was B into A, right? So we are talking about first row into first column, that is fine. Then first row into second column, right? So this is 0 and 1, that will be 1. Then we talk about second row and the first column. So second row and the first column, that will be 0. And we talk about second row and the second column, that will also be 0. So this is not a null matrix. So it is also an observation here which is very important, that both A and B exist, and A and B are of the same order, 2 cross 2, still both are not same. One is null matrix, another is not a null matrix, and here A and B both are non-null matrix. So anything of this situation may happen, and you should not get confused. So these were some of the basic concepts regarding matrix multiplication, and it is a very important concept, and we have many more concepts like this in the chapter matrix, and you have to be quite aware about all those concepts to solve the problems. So we will meet again, students, with some new concepts, and keep watching. Thanks a lot. All the best.